add our new maths understanding to our number mind map. Today we've been looking at place value. And we know that we've got units, tens, hundreds, thousands, tens of thousands, hundreds of thousands, and a million. We also know that this group here are called our thousand family, and we can remember that they're grouped together using the commas. We also have learnt that we can visually represent our place value by using 1 cube for our units, rods of 10 for our tens, that's 10 of these units stuck together to make a rod, a square for our hundreds because we stick 10 of these rods of 10 together when we get them to make 100, and then a cube for our thousands. We also know that we're working in a base 10 system. Our next video will be working on looking at place value with decimals. Okay, so we're going to add our new learning to our mind map. We're still looking at place value, but this time we were looking at decimals, and we need to include our decimal point. We know that decimal point means that anything after the decimal point is smaller than 1 unit, and it's similar to fractions. Well, it is like fractions. That we have a tenth, hundredth, thousandth, and a tenth, tens of thousandth. That a tenth is 1 unit that's cut up into 10 pieces. You're not going to be able to see that, don't worry, it's just to remind us. And a hundredth is 1 unit that's been cut up into 100 pieces. Again, you're never going to see that, but it's just there to remind us. So we're going to add our new learning to our number mind map. We've been looking at add, and what does add mean? We said that we can use the word add, addition, sum, total, an increase, and plus. We knew that we had got an amount initially, and this symbol meant that we were going to add more. We were going to make an increase, we were going to make the number bigger, so we were going to add 2, so we were adding on to our current amount so that we got the number 8. We also talked about our fluency with addition. Fluency means that we're doing things quickly, more efficiently, and that we did it in as little steps as possible to make the calculations easier for us. When we were doing add, we looked at doing the part-part whole diagrams to help us remember number facts or addition facts. So that we knew that 3 and 4 is the same as 7. We also looked at our number bonds to 10 facts and number bonds to 20 facts. And in fact, we could use the bar model to help us work out, investigate and remember our number facts. And we gave the example that 3 and 7 were number facts that made up 10. So, if we're going to link our previous learning to our new learning, we used our understanding of place value to help us work out what addition means. So, we're going to add our new learning to our number mind map. We've been looking at mental addition, and we were using a number line to show what was going on inside our heads when we were doing it mentally. We were also using base 10 to show what that actually meant. We were adding the tens, we were adding the units. We were also being more fluent by rounding up to the nearest 10 or rounding down to the nearest 10 and adjusting. We used our old fluency understanding to help us with our number lines. We knew that things like 6 add 2 made 8, so we therefore adjusted on that basis, and we also used our understanding of place value to understand what that meant on the number line with base 10. Okay, so we're going to add our new learning to our number mind map. So we're going to go from mental addition and we're going to come up here to column addition. We've just learned that in column addition we need to make sure we're lining up our sums in the columns, and it would be a good idea to make sure that we line things up around a decimal point if we're going to be adding decimals. We know that we're going to be adding the smallest column first. We also know there's something about carrying as well, and we carry onto the next column or the place value column when the number is 10 or bigger. How's that linked to our previous understanding? We used fluency again to help us quickly add up those two numbers so that we could come up with our answer. Place value helped us with our fluency, also helped us out with our column addition, and we knew that we could use column addition if our mental strategies got a little overloaded. So we're going to add our new learning to our number mind map. Here we've just learned about subtraction and the different words for this symbol here. So we have minus, decrease, difference, reduce, and fewer. And we're also remembering that when we're actually subtracting, that first number, this initial number, is the number that we're going to be reducing or making smaller. So let's put our new learning onto our number mind map. So we were looking at mental, subtraction, and we were using a number line, and we were using base 10. And we knew that we needed to reduce the initial number, and that way we were going down the number line. We were also using our fluency understanding, and so we were rounding up to the nearest 10 and then adjusting. Okay, we look at where that learning can be linked to. It's exactly the same as when we were doing mental, here we go, addition. Exactly the same techniques, it's just that last time we were moving forward because we were making the number bigger, and this time we're moving backwards because we're trying to reduce the number, making the number smaller. Also, our fluency understanding, we used a lot for this mental subtraction. So I'm going to take this arrow here from our fluency and link it up here because we were doing exactly the same thing. So let's add our new understanding to our number mind map. It's starting to get a bit more confusing, this mind map, but we understand it at least. So we've gone from mental subtraction to column. We put everything in columns. We also helped by lining up our place value positions. We knew that if our initial top number was smaller than our bottom number, we'd need to do something called decomposition. Which meant that we need to steal one of the place value positions and put it over here. We also knew that if we had 0, 0 and then a unit number, we'll go for 3 here, and we were taking off a smaller amount, we'd have to steal from here, make that tenths 10. We'd still have a problem with the hundredths, so we'd have to make that 9/10 and that 10/100. How does that understanding link? You can see it's very, very similar to column addition. Instead of carrying, which was going on to the next, we're actually using decomposition. I like to call it stealing because we aren't ever going to give it back. And they're the only differences between the two strategies. One is reducing, one is making it larger. Let's put our new learning onto our number mind map. And we're looking at place value, and actually all we were doing was ordering. Using our equals to, our greater than, and our less than sign. And remember we said with our greater than or less than, the biggest number goes to the biggest opening, and the smallest opening points to the smallest number. We said that equals was a balance. It meant the same as. So I'll do my quick picture. The children at school did of Mrs. Williams minus her hair, so a reduction of her hair is the same as a bold Mrs. Williams. So let's put our new understanding onto our number mind map. So I'm going to draw a very, very long line and come down here to multiplication. We know it's this symbol here, and we know we've got groups of, lots of, got an array, we've got repeated addition, times, multiply, and we know all it means is exactly the same as repeated addition. If we had 3 groups of 2, we'd have 3 groups with 2 in each group, or we'd say it's 3 repeated twice. We use the bar model to help us. And we also knew that by using repeated addition, we could very easily work out times tables that we weren't sure about. So, how can we link our previous understanding? We used mental addition to help us with repeated addition. And we also used place value and base 10 to help us work out what the multiplication meant. So we're going to add our new learning to our number mind map. Here we talked about repeated addition and writing it down. We then said that you would go on to saying it, and also you can learn it by playing games. We went on to www.topmarks.co.uk. We also learnt that timesing by 2 was doubling, timesing by 4 was double 2, timesing by 8 was double 4, timesing by 6 was double 3, timesing by 12 was double 6. We used our fingers, that's a better picture this time, for our 9 times table, and we knew that timesing by 5 was the same as halving timesing by 10. Okay, so timesing by 10, 100 and 1,000. We're going to put it here with multiplication. And here we were going to just move it up the place value position once. Timesing by 100, we're moving it up twice. Timesing by 1,000, we're moving it up 3 times. Okay, adding to our number mind map, we have done tens and units times a unit and 100 tens and units times a unit. We looked at the bracket method and we looked at the carrying method. We also checked our answers using repeated addition. So we used our understanding of column addition to help us with our repeated addition, and we also looked at the carrying strategy when a number was less than or equal to, more than or equal to 10. Okay, adding our new learning to our number mind map, our growing number mind map, we were looking at 100 tens and units times tens and units and tens and units times tens and units. And we had to take these tens and units and we had to partition them. And we also need to remember when we were doing the 100 tens and units times the 10 that we needed to put in that 0 placeholder so that we could make the number 10 times bigger. That was in the units column. Linking our previous understanding, where we learnt how to make a number 10 times bigger, we needed to apply that understanding in order for us to understand why we put that placeholder in. Let's add our new learning to our number mind map. We're going to put a new branch from here up to here because we're looking at division. And we said we've got groups, shared equally, we had divisible, divide, divide by, and we used our picture representation to see what it meant. So we knew that there's 2 ways of doing it. We could share it, we gave the example of the flowers in the vases, so we could share them equally between 3 vases, or we could group them. Remember, we were talking about bunches, so grouping the flowers into bunches of 3. There we go. We also talked about remainders. And that's when we had some left over. We couldn't share them equally.
Okay, let's add this bus stop knowledge that we've just learnt to our number mind map. So we're going to write it over here, as this is our division section. So, we looked at the bus stop. Whoops. And we know the bus stop looks like that. We also said that we could do it kind of in 2 ways if we had a remainder. We could either do it like that with a remainder, or we're going to use our decimal place if we're going to be looking at decimals or using decimals. And we also have quite a bit of linking to do here. Now here, this is quite an entertaining one. We're using our times tables and we've got to link that to our division. We use it quite a lot. I'm going to be using it quite a lot as we go along, so I'm going to draw it all the way around here.
Okay, so let's add long division to our number mind map. So, we're going to go off bus stop here. I'm going to put here long division. We use it when the divisible number is a tens and units or it's 100 tens and units. We also use the bus stop method to do it, but remember we were bringing down arrows to help us once we were going along, and we could have remainders or we could have decimals. We used column subtraction to help us take off how many lots we had worked out. And we come down to here, we used our multiplication understanding, and I'm going to steal that link there that went before, to help us to create our fact bank in order for us to work out how many lots to be taking off. Okay, so let's put our new dividing 10, 100 and 1000 learning onto our number mind map. We were looking at division, so we're going to come here, and we were looking at dividing 10, dividing 100 and dividing 1000. And when we divided by 10, we moved it 1 place down the place value position. When we were dividing by 100, we moved it twice. And when we were dividing by 1000, we did it 3 times. Okay. Now this links. We go all the way down around here, exactly the same understanding as timesing by 10, 100 and 1000. And it also links to our place value because we needed to use our place value position understanding in order to do it.
Okay, let's add that knowledge to our mind map, our number mind map. So we're going to go into this corner down here, and what did we learn? We learned units, so decimals multiplied by a unit. We also did tens and units multiplied by a decimal, and we did, multiplied by a decimal, and we did decimal multiplied by a decimal. And what knowledge did we link in there? Well, we used that knowledge from our column multiplication. We used column addition to add the answers together at the end. And here, if we look at this section, we actually had to use our multiplying by 10, 100, 1,000 and dividing by 10, 100 and 1,000. So I'm going to do a little carry off there and take it all the way around here to that.
So we're going to put multiples and prime numbers on our number mind map. So we're going to start moving ourselves towards this area here. I'm going to put multiples. Multiples are numbers that are in certain times tables. So we know that 21 is a multiple of 3, it's a multiple of 7, it's a multiple of 1, it's a multiple of 21. We also talked about common multiples. And that's when a number shares its multiple with a multiple shares itself with another number. We looked at Venn diagrams and we said that the common multiple would go in the middle. So if we had 21 and we were looking at multiples of 7 and multiples of 3, 21 is a common multiple, it's going in the middle. Whereas 3 is a multiple of 3 and 7 is a multiple of 7. They're not common, they don't share that particular multiple number. We also talked about prime numbers and how prime numbers are only in the 1 times table and their own times table. And we said that 1 was not a prime number, but we had 2 and 3 and 5 and 7 that all were prime numbers. So, where can we link our previous learning from? Clearly we were talking about multiplication, so we've got to make that link between multiplication and multiples, and also prime numbers to multiplication as well. I'm going to link prime numbers and multiples together because prime numbers are not multiples of any other number but itself and 1.
Okay, let's put our knowledge, our newfound knowledge of factors onto our number mind map. So we're going to add it here for ease by multiples. So we have our factors, and if you remember, our factors are something that's divisible but with no remainder. And then with that I could find a common factor, which are factors that are factors for 2 different numbers. I could have had a factor pair. So let's say, for example, we could have had 36 and we said 3 and 12 are factor pairs. And then we could have factor trees, which find prime factors. So, what does this link together? Well, multiples and factors, as we know, are very much linked together. The multiples of one factor is going to be the factors of the other multiple. For example, 21 being a multiple of 3 and 7 and 1, actually these are all factors of 21, so it's the other way around. Factor pairs are then linked to multiples as well, and so of which prime numbers and prime factors and factor trees all together as well. Now there's going to be loads, way too many arrows, so I think that is enough arrows from our factors, prime numbers and prime factors. One last link that we need to do, factors link to division. So I'm going to go all the way up here and then cross over into our division. Okay, how does that link to our number mind map? Well, actually, I don't need to write anything on there, but we are going to use a new colour, green, for the inverse. Here we have addition is the inverse of subtraction. And, a bit more of a technical jaunt, but division is the inverse of multiplication. Snake its way down there. And while we're on the subject, we can scan over to here, and multiples are the inverse of factors, the same as factors are the inverse of multiples.
So let's put our new learning onto our number mind map. We're going to go up to here to place value. And I'm going to stretch and write rounding here. We round it to the nearest 1,000, 100, 10, units and tenths. We knew that we needed to use a number line to help us out. But actually the rule could say if we've got 1, 2, 3 and 4, we're going to round down. 5, 6, 7, 8 and 9, we're going to round up. So let's put fractions onto our ever-growing number mind map. It looks very complicated, but if you've gone through all the videos with us, then this will make complete sense to you. So we're going to go up here, past place value, up here to fractions. Remember, we said the top of the fraction is the numerator, the bottom is the denominator. The numerator is how many we're looking at, and the denominator is how many pieces make a whole. We talked about saying the fraction, that the denominator is like a race position. Apart from when we've got the denominator of 2 or the denominator of 4, because we call that a half, and we call this a quarter, or quarters. We looked at drawing fractions out to see what they meant. So we had 1/5, which was the same as 1 whole rectangle. Remember, we don't want circles. We can't cut those up equally. 1, 2, 3, 4, 5. And we needed to split that whole into equal pieces. And the numerator was how many we were looking at. We linked that understanding through all the way down here to our tenths and our hundredths and our thousandths and our tens of thousandths. Because remember, we said that a tenth was 1 whole unit cut into 10 pieces, so that's exactly the same as our fraction. That would be 1 whole cut into so many pieces.
Right, welcome to our ever-growing number mind map, and we're going to be zooming up to here so we can put our unit and non-unit information on. Simply put, unit fraction equals a numerator equaling a 1 and a non-unit fraction equals a numerator of anything greater than 1.
So we're going to add our new learning of fractions of a number to our number mind map. So I'm going to do a very long line to here, where I'm going to put fractions of a number. Remember, we drew it out, we shared the number, we looked at the numerator, we shared it using the denominator, we looked at the numerator and we multiplied how many we were looking at it. With Mr. Slay's version, it's just the same as this but without it being visual. We had the number, we shared the number across the denominator, and then we times our answer by the numerator. We also talked about how of was the same as multiply, thanks to the key skills confusion this year. And we're going to have to do a lot of linking for this, which is good news because it means that we've already used our previous understanding. So bear with me, there's going to be a lot of lines going round. We're going to come down here and along to multiplication, because we had to use a multiplication facts to share it out, and we also had to use a multiplication facts to times it by the numerator. Back up, and we're going to go up here. We're going to go all the way over to division, because we had to share, we had to divide that whole number by the denominator. Okay, so we're going to put our equivalent fraction understanding to our number mind map. We're going to come up to where we had fractions of a number. I'm going to come along here and I'm going to put equivalent fractions. Remember, they were the same fractions but with different numerators and denominators. I'm going to show that by having capitals there so that you know that they're the same fractions but they look a little bit different. And all it meant was that we were using our multiplication skills to times the numerator and the denominator. We could also use division skills, but Mr. Slay's going to go into what simplifying is in the next video. And all it meant was that we were cutting each section into smaller parts. To do that, we used our multiplication understanding and our fraction understanding by doing our investigation.
Right, to our number mind map, and getting very complicated number mind map, we're going to be zooming into this section here to look at our simplifying fractions. Okay, right, simplifying fractions here. And if you remember, simplifying fractions, actually I'm not going to need to write a massive amount here because what we need to do is really link this information to other information that we've had before. So I'm going to be linking it to our equivalent fractions here, because here we were dividing. I am going to write that simplifying fraction means a fraction in its simplest form. We needed to use our multiplication knowledge, and we needed to use our division knowledge. We also, if we were using a fluent way of doing it, we needed to use our common factor knowledge. Right, to our number mind map, and we need to add ordering fractions to this. We're going to put it here around our simplifying fractions because we have a lot of linking to do with it. So I'm going to put ordering fractions. And with ordering fractions, we know we need to find a common denominator. Put that in brackets just so we know, and we know that we need to simplify the fractions sometimes, or we need to find equivalent fractions for these using our common denominator. We can use that by helping with our multiples, so let's bring one from here. And when we're writing them out, we could order them using our ordering symbols, greater than, less than, or equal to, if we need to.
Let's add our improper and mixed fraction understanding to our number mind map. So we're going to go up to where we had fractions, and we're going to go up to here, and I'm going to put mixed and improper fractions. Improper fractions is when the numerator is bigger than the denominator. And we used our understanding of drawing out fractions to help us. We also used some multiplication and division to help us work that out. So, here we go. I'm going to come through here and onto this multiplication line. And I'm going up here to our division line to show that we use that understanding to help us work it out. So we're going to add our adding fractions to our number mind map. We're going to be going around here, so fractions of a number. And I'm going to write here adding fractions. Now it's easy to add simple fractions. That's when the denominators are the same. For example, if I had 1/5, add 1/5, it would be the same as 2/5. When we have mixed denominator fractions, we have to find a common, sorry, my handwriting's horrendous, denominator, and then we can again add them simply. What learning did we get from this? Again, we had to use common denominator understanding, which is the same as equivalent fractions. And we needed to use our understanding of addition, which is all the way over there, which I think I'm going to have to come around here. I also used our understanding of improper and mixed fractions, which is up here. So I'm going to come round, use this line and steal it on here as well. Okay.
Alright, moving on to our number mind map, and we're going to add our subtracting fractions just above our addition fractions here. So, subtracting fractions, when it's simple, when we have a similar denominator, and again I could write that the same way as Mrs. Williams did. And then if we need to find a common denominator, if we have a mixed one. So for example, 4/5 take away 2/5 equals 2/5. Now, I have some linking to do. I can use my fraction information, so I'm going to create a little link off there to come from my fractions. I can also need to link my multiples to this, and actually my addition multiples need to link to that as well, so I'm going to follow this line here, and then I'm just going to come off there as well, and then I need to come up to my subtraction, so I've got to come all the way up here, up through the top, keep going, and then cut through this line to subtraction. Finally, I have an inverse. I haven't had one of these for a while because adding fractions is the inverse to subtracting fractions.
So let's put our multiplying fractions onto our massive number mind map. So I'm going to go around about here. I'm going to put here timesing fractions. We've just learnt the numerator times the numerator. We times the denominator by the denominator to get our answer. We also drew it out to explain what that meant, and we're only looking where the two met. So, where have we linked our understanding? If the camera can follow me up, we're going to go up to mixed and improper fractions first. And actually, this goes all the way round. I'm going to have to...
No, it doesn't.
No? Oh no, I've gone the wrong one. So I'm going, this is like snakes and ladders. I'm going down here, down, past factors. I'm going to come through here because we used our mixed and improper fraction understanding. We also come up here to fraction of a number. We talked about how of was the same as the times sign. So I'm going to follow this one down here and link it to timesing by fractions. Going over to multiplication, because we used our multiplication understanding in order to answer the questions. And I think that's about it for all of my red lines. Okay, so we're going to put our dividing fractions onto our number mind map. So we're going to go up here in our mind map. I'm going to put here dividing fractions. Do you remember we were going to put things into groups when we're dividing? But actually we realised that it was a lot easier. We understand what we're doing when we're dividing fractions. But all we do, I'm going to choose a different colour here, is we're going to do the inverse of division and swap our numerators and denominators around and times along accordingly. So where does that fit in? It fits in perfectly with multiplication of fractions. I just don't quite know how I'm going to get there. So, let's see how this pans out. Let's go up here. Oh, this is such a mess. Okay. And along that line, I'm also going to draw a green inverse line, because we truly know that division is the multiplication of... division is the inverse of multiplication when we're looking at multiplying and dividing fractions. We also were using our times table understanding, which again is all the way down there. So I'm going to come round. Oh no. Sorry, I know that's a bit quick for the camera. And we'll go in that way there as well. And we also had our division understanding when we were drawing it out. And when I come from here, I think I've massacred our, oh dear, that was horrendous, into there.